Hey guys, today's video is going to be a quick review on adding fractions. This should be something that you learned in elementary school, so we're just going to do a quick review. First, when we look at adding fractions, we have to check out the denominator. In this case, I can see that both denominators are 5. What does that really mean? Well, if I had a rectangle and it was broken up into 5 pieces, and I have another rectangle also broken up into 5 pieces, and I have 3 pieces over here and 1 piece over here, that would give me a total of 1, 2, 3, 4 pieces when they're broken up into 5 parts. So 3/5 plus 1/5 is 4/5. Pause the movie now and copy this example into your notes. You do not need to copy the rectangles. Let's move on. Sometimes you're going to have fractions that have variables in them. First thing we always look for is the denominator. Are the denominators the same? In this case, they are. So we know that our denominator is going to be 3. And then for the numerator, we're going to take 2x and add it to 4. I look at those terms on the top. 2x is a term. Positive 4 is a term. I know those are not like terms. So 2x plus 4 over 3 would be my final answer. Pause the movie and copy this example into your notes. Sometimes the denominators are not the same. In this case, 3 and 5 do not have common denominators. So I write them like this, 3 and 2/5. I want to look for the least common multiple that I can use for a common denominator for these numbers. I start with my biggest number, 5, and I'm looking for a number that 3 will go into. Well, 5 times 1 is 5. 3 doesn't go into 5. 5 times 2 is 10. 3 doesn't go into 10. 5 times 3 is 15. 3 goes into 15, so that I know my common denominator is going to be 15. So now I need to convert these fractions to 15ths instead of thirds and fifths. To do this, we use the giant 1 that we learned when we learned to find equivalent fractions, because these are actually going to be equivalent fractions, but with a denominator of 15 instead of 3 or 5. So I ask myself, 3 times what is 15? Well, 3 times 5 is 15. And since I want this to be an equivalent fraction, I'm really just multiplying it by 1, which will be 5 over 5. So 3 times 5 gives me 15. So 1 times 5 would give me 5. Let's try the bottom one. 5 times 3 is 15. What I do to the bottom, I have to do to the top. So 5 times 3 is 15. So 2 times 3 is 6. Now I can add these together. 5 15ths plus 6 15ths is 11 15ths. Add my whole numbers. Don't forget about those guys. 2 wholes plus 3 wholes would be 5 wholes. So the answer would be 5 and 11 15ths. Pause this movie and put this problem into your notes, showing how to find common denominators. Sometimes it's not so easy for students to see which common denominator they should use. So let me show you another way that I teach students to find common denominators. And all you have to do is be able to know how to count. Let's look at 1/3. I can list all of the multiples of 1 and 3. So let me just start my list now. 1, 2, 3, 4, 5, 6, and so on. How about the numbers on the bottom? 3, 6, 9, 12, 15, and 18. All right, well, let's try 2/5. This time we're going to count by 2s and 5s. 2, 4, 6, 8, 10, and 5, 10, 15, 20, and so on. I can actually stop right now because I can see my common denominator is 15ths. Some students think this is too much work, but if you're not able to find the common denominator right off of the top of your head, sometimes it's easier to list these equivalent fractions to come up with the common denominator. So now I can add my 2 plus 3 and get 5, and my 5/15 and 6/15 gives me the 11/15. If you think this is a strategy that you might find useful with adding fractions, copy this into your notes. Let's try subtracting fractions. I'm going to use the long method that I showed in the other example. Actually, I changed my mind. I'd like you to pause the movie now, try to find the common denominator, and subtract, and see what you get for your answer. All right, let's see how you did. In this one, we're going to list the multiples. What's that going to look like? 7, 14, 21, 28, 35, 8, 16, 24, 32, and 40. Let's list the multiples of 1 and 6. 1, 2, 3, 4, 5, 6, 12, 18, 24. So, since I can find that common denominator, I'm going to stop right there. 21 24ths minus 24 24s is 17 24s. Check to see if you got this one correct. If you didn't get it correct, go back and check your work and fix your notes so that it is done correctly in your notes. Let's try one more together. This example, 2 1/4 minus 1 3/5. I can either list my multiples to find a common denominator, but if I look at 4 and 5, I know that both of those numbers go into 20. So I'm going to use my giant ones. I know that 4 times 5 is 20. What I do to the bottom, I have to do to the top. So 1 times 5 is 5. I know 5 times 4 is 20. And what I do to the bottom, I have to do to the top. So 3 times 4 is 12. Now I've got a problem. 5/20 minus 12/20. I can't do that because I know the answer is not going to be negative. So we have to borrow. What I do is look over here to my whole numbers. And I say, hey, 2 wholes, I need to borrow one of you. So I'm going to make you 1 whole. And that whole that I just took from you is going to be 20 out of 20 since we're using a denominator of 20ths. Well, that 20 out of 20, or that 1 that I just borrowed, now makes this fraction 25 out of 20. And I can take my 25/20 minus my 12/20, and that will give me 13/20. The wholes, 1 minus 1 gives me nothing, so my final answer is 13/20. Please put this example into your notes where it teaches you how to borrow for subtracting fractions. Some teachers teach you how to change these to improper fractions and then subtract. That's fine too, but sometimes the problems can be pretty challenging and give you really large numbers. Now I want you to try these on your own. Complete problems 1 and 2 and fill your answers in on the class form.